Firewall. Now, today we are going to cover the initial topics understanding the basic structure of the FortiGate firewall. Okay, and we will see that how we can bring up the labs also with terms to continue further in the general configurations and all, right? So today only we are going to cover basic structure of the firewall. We will see how does the firewall process the packet, and then if the time permits, then we will also see how to bring up our basic lab. Okay, so that is the agenda for the day. Now, let's start with. And yes, needless to say, if at any point of time you have the concerns and all, you just have to speak it out. Okay, do not wait for a start or end or midway, nothing like that. Okay, whatever comes in the mind, stop me, ask your question. Okay, if you feel that I'm going in a much pace, tell me, I will go slow. Or if you feel that I am going in a slow, you want me to take the pace, I can also take that. Okay, so be upfront how you want to proceed. Okay, so let's start. Fine. So see here. First of all, Fortinet. Okay, so we are going to learn with reference to the FortiGate firewall, which is designed and built by the Fortinet. Okay, so the point is, this company makes several products. Okay, FGT, which I'm talking with reference to the FortiGate firewall. Okay, FMG, which is your Forti manager. FAZ, okay, Forti analyzer, which is used for logging and creating the custom report. FMG is used to manage several Fortinet products from a single platform. Okay, so that is what it is used for. FAP, which is access point, just like your Wi-Fi routers and all. Okay, Forti switch, a normal layer 2 or layer 3 switches. Okay, you have Forti auth, okay, which is used for managing any kinds of authentication that you want to, and also it can help you to generate as many certificates that you want in your network. Okay, you also have FortiWeb. Okay, so FortiWeb is SWG appliance, okay, which is used as a security web gateway, and it's mostly a proxy device. Okay, just like you have Prisma solution or Zscaler products. That's how you also have a FortiWeb. Okay, which is still in a development phase to improve its functionality in much more better way. And there are few more also, like FortiSIEMs, separate Forti as SDs, and likewise. Okay, so we are going to focus with reference to the FortiGate firewall only. Okay, this is a NGFW firewall. That means by definition, a firewall is said to be a next-gen firewall if it supports IPS functionality. Okay, so if any device is capable to give you a IPS functionality, that device is referred as next-gen firewall. Okay, so that's why you will see that any firewall like Palo or Sophos, Checkpoints, right? Even the Juniper has an ASICs, your Fortinet has the FortiGate. They all are capable to give you the IPS functionality. Please note, the IPS is the one which is responsible to provide UTM functions, Unified Threat Management. Okay, so that's why the firewall, the older firewalls has been reframed with reference to an IPS function and now been referred as a next-gen firewall. Now, what is this IPS function? What is the UTMs and all? That is something which we will see when we will start the UTM topics, which is are quite far distant from now in here. Okay, so just for now, know that if your device supports an IPS function, it's an NGFW device. That's all. Okay. Now, see, since we have to learn and understand in order to troubleshoot the FortiGate firewall, right? After all, no matter what concept we have, we are going to learn, or like we will learn in future as well. The motive is to troubleshoot the firewall, right? I should be able to manage, configure, as well as troubleshoot the FortiGate product. That is what we do, correct? So if we want to do that, the first step to learn our product is to understand its architecture, the building blocks of it. Okay, how is the device? What is the basic structure of that device? How does it function? Okay, and the most important question is that if I have a firewall or any device that there is, okay, I have sent a packet. The packet would have been received on the incoming interface, right? And the packet would have been sent out from the outgoing interface, correct? So what did the firewall do? Something would have happened. The firewall would have done something when it received a packet and when he sent it out. Between that, he would have checked the routing. He would have done some UTM checks. He would have verified the SSL handshake. Something he would have done, right? So what is the life of packet inside the device? That is really important to know. Okay, so that is what I will try to address in today's class. Two things: architecture of the firewall, and second, which will be followed by the life of packet. Okay, so let's start. Let me draw a diagram. Okay, so this is FortiGuard.
So, FortiGate it's type of VPN or
I'm sorry, what?
what is FortiGate?
Yeah, I will come to that. Let me just draw the diagram, okay? Let me just complete the picture, then we will discuss everything thoroughly. Okay. Okay, let's say this is AB, this is IPS, this is WF, this is something else, TF or something. Okay. This is your FortiOS. This is your CPU. Okay. Okay. Now see. So this box here is your FortiGate firewall. Okay, this is your FortiGate firewall. So I've just drawn a block structure diagram. Okay. So this is your FortiGate firewall, and when there is a packet which has been received in here, okay, so this is the firewall which will be processing it. So the packet will be processed through several things like routing lookup, VPN functions, policy lookups, right, NATings, your SSL inspections, IPS, antivirus, web filter. Okay, everything will take place onto that packet if everything is found, and then it will be sent it up, right? Now, see, with reference to the diagram of the firewall, first thing, to understand the structure of the FortiGate firewall, let me take an example of your laptop or desktop, anything like that. Okay. So let's say if I have gone and like bought a new laptop. Okay. So if I buy a laptop, can I install the applications like Microsoft Office, Teams, or Zoom onto the laptop directly without having any operating system? It's not possible, right? If I need to install a Chrome or any browser or any kind of an application, I must have what? An operating system installed onto the hardware. The reason behind that is what? So that my applications, like for an example, Chrome needs a certain CPU and memory resource in order to execute it itself, right? Whatever the process and like function it is supposed to do that work, he needs a certain CPU and like memory, right? So how he will get it? Through our operating system. So OS is acting as a bridge with reference to the process which wants to run and make a usage of the certain CPU and memory. That's why you see in the task manager and all, you will see several processes on, right? Correct? This is what you see now. Yes or no? A certain process.
Yes, yes.
So these are the actually, which is making use of a certain CPU and memory, right? Disk and all that, all kinds of things. So if I'm having a conditioned CPU and like memory, but it does not mean that I can run the applications on it. Okay, so I need an OS. This with the same logic. Okay, in the FortiGate firewall, you have a operating system which we call it as FortiOS. Okay, so FortiOS is our OS platform, which you will install on your hardware. That hardware can be a virtual or that can be a physical hardware. Okay, whether it is a low-end device, medium scale device, high-end device for the enterprise labels, whatever that capacity is. Okay, just like in laptop, we also have a low-end laptop, something which is better than that, some like medium scale models or maybe some high-end laptops, right? Similar to that. Okay, so you will install the FortiOS. Please note the FortiOS family series has started from 4. Or even before that. Okay, but 4.x, 5.x, 6.x. Okay, in 6.0, 6.2, 6.4, 7.0, 7.2, 7.4. These are the series of the OS that has been released so far. From 4 to 6. I think 6.4 is still supported, but till 6.2, these are out of support. Okay, no one supports now. Okay, even if you are running these OS onto your firewall, you will not get a proper TAC support with reference to these firewalls. Okay, but you can work on these devices. It's like if your devices is running on 6.4 or 7.0, 7.2 or 7.4, then you are in a good condition now. Okay, the major shift happened from 6.4 only. The major shift happened from this point. Okay, so you will see a lot of changes as far as the GUI is concerned with reference to 6.2 version towards 6.4. Okay, the lab what we are going to do is with reference to 7.0 only. Okay, so we will be running our lab with reference to 7.0.0 software, which is one of the latest software. Okay, now that being said, see here. So just like I said that there are several processes in the firewall, right? So all those processes needs a certain CPU and memory resource. Okay, now the processes like VPN process, which we call it as an IKE process. For the authentication, we have authd and FNBAMD processes. Okay, for the DSCP, we have DSCP-S, DSCP-C, DSCP relay processes. For the DNS, we have process called DNS proxy. Okay, for the URL filtering, we have a process called URL filter. For the IPS, we have the process called IPS. For the your command line, we have a CLI new. Okay, and likewise, there are many other processes. So the point is like for each and every task, there is a dedicated process. You can call the process same as an application. Okay, so if you are running a VPN, so your process that is responsible to maintain and negotiate the VPN is called IKE. Okay, so that I process needs a certain CPU and memory resource to run over the firewall. Okay, so that's the simple analogy. Okay, clear with this point? Okay, just like how you have Chrome or any other application running on your desktop or like laptop in the same fashion. Okay, now what are each and every processes into the FortiGate firewall? Do not worry about that. Okay, because as soon as we will progress through the courses and all, you will come across to know all the processes. Okay, now the next thing is, see, your firewall, okay, will also be efficient enough to receive the latest database with reference to antivirus, signatures, URL ratings, attacks, right? As well as categorization. So who will give that latest database? Let's say someone sitting in New York, okay? He saw some new virus or like malware. Now I am sitting in India, right? My like company location is in India. Now someone in US has got that virus. So does it mean that I will not learn it? Or maybe till my network has faced that problem, till that I have no clue what that the virus is, right? So those days are gone. Now we all are having a centralized cloud-based database. So this is what your FortiGuard is. FortiGuard is a centralized cloud-based database or like cloud-based servers, which constantly keeps on pushing the latest database with reference to viruses, malwares, greywares, outbreaks, URL categorization, application categorization, attacks, as well as ratings to the licensed products. Okay, let me show you this. See it. This is your FortiGuard.com. Okay. Now see the services, like I will take an example of antivirus. Let's take an example of an antivirus. Okay. See here, in last 4 hours, there have been 5 releases of the database.
Bro,
Yeah.
are you
Sorry
sharing the
to,
screen? We could
yeah,
not see.
Rohan.
You
We
are not.
can see only paint screen.
Yeah, yes.
Okay, let me reshare my screen. Okay. Let me do that. Is it fine now? Do you see my screen now?
Yes, it's
Okay.
okay.
So I am accessing the FortiGuard.com. Okay. See here the services. Let's say I'm choosing antivirus. Here you will see that. Okay, I see one message. Voice not coming. Is my audio clear, guys?
Yes, it's clear.
So see, in last 4 hours, there have been 5 push. Okay, the database versions. Okay, you can see that in every push, something has been added or something has been modified. Okay, so it's like keep on improving. Okay, so the whole motive behind is that if someone sitting in the North Pole has seen something, the person sitting in South Pole should also be aware of the same thing at the same time. Okay, no delay. Okay, so if a person sitting in US has seen a virus, the device has learned it, it will automatically if there is no question. Okay, so that like information will be passed on to all products deployed throughout the globe. Okay, so in this way we keep each other it's like safe by like keeping the database up to date. Okay, so it's not only with reference to antiviruses and all, there are a lot more services with reference to it. Like I said, categorization, right? So like if I go into the web filtering, so you can see that these many URLs has been identified and blocked by the FortiGuard. See how efficient this is, okay? And you search anything, okay? CNN.com or any website you do search it, it will tell you that this website falls under which category. Okay, so it's easy for you to take an action while what you want to allow and what you not. Let's say the client has asked you to block any traffic which is related to terror, okay, which is like related to violence, which is related to ex, ex, extremist thought. Okay, so how will you do that? Can you maintain the list of those websites? Maybe, but like, what is the guarantee that tomorrow, the next moment, there is a new website launched with like reference to the same content, right? So you do not have to worry on to like that, but we will simply go in the policy and like we'll simply add a block for the URL category called violence or terrorism, something like that. Okay, we will see that in like further topics. But the whole like point is FortiGuard is not just a cloud-based server which is only there to give you the database with reference to antivirus or the attack. FortiGuard is also there to help you to get the ratings, to help you to get or act as a DNS server, okay, to also help you to host the domain or like map your firewall to a domain. So you can also get a DDNS functionality. Okay, it can also help you to achieve the SMTP functionality to send the alerts throughout the globe. Okay, wherever you want without any single charge. The only thing you have to do is that your firewall must be a licensed one. That's all. Okay, so when you buy a normal bundle license, you get all these features to it. Now,
Sorry to interrupt you, Ron. So the FortiGuard service. So is this 6.2 version supported FortiGuard service or not?
the 40 OS version.
Yeah, like 6.20.
No, it has nothing to do with your FortiGuard.
Okay.
Irrespective of the 40 OS version, what you are running on the firewall, FortiGuard is going to give you the database in the same manner what it would give for the latest version. So it like
Yeah, actually, when you share your screen on CNN, so it was showing 7.0. So I'm not sure, like, is it also?
Where you're talking about? Here.
Yeah.
No. This is the list
Okay.
of based upon, let's say 5.4. What was this? The categorization was still it is news and media, right?
Okay.
So that is what it is. Sometimes what happens is, like, let's say, for example, when the 6.0 version was released, okay, CNN.com was categorized as news and media. But afterwards, customers started reporting that, hey, CNN is not a news and media site, but rather it's a, let's say, IT site, okay? It's like kind of an IT industry site. So please modify the category. So when the next release will come, they will modify this category. Okay.
Okay. Thank you.
That is what it is. Okay. But mostly we will see no matter what you choose, it will fall under the same thing. Okay. Fine. Now see this. So see so in short, what is happening is your firewall is syncing up with the FortiGuard to get the latest databases or whatever the information that it needs from the FortiGuard. It will sync up with that. Your processes, whatsoever that process is, which is running on the firewall, is communicating with the FortiOS. Your FortiOS in return is communicating with the CPU or like memory. Okay, clear? So this is a basic structure flow. Clear up to this point before I move further?
Yes.
Okay.
It's clear.
Now see, the thing is, let's say we are trying to let's talk about like we are trying to sell our product. Okay, so the client is finance related client. Okay, like someone who deals in stocks and all. Okay, so he is that client, and we are trying to sell our product to it. He has a basic question for our product. Okay, the general in like layman term, who is not such a technical guy, so he's simply putting up the questions in a layman term. He's saying, hey, look, I have a router in my network. Okay. The router is supposed to perform major functions like routing lookup, policy lookup, policy lookup, NATing, major functions. Okay, I'm just taking a layman example in that term. So if a packet is being sent to the router will perform these three functions and then it will send it out. Let's assume that each function took 1 milliseconds at its best. Okay, let's assume that just for the sake of numbers. Okay, so the total time taken by the router to forward the packet is 3 milliseconds, right? Okay, so this is what it's like. Currently I'm having a router in my network, and my router is adding 3 milliseconds of latency into the network because it is supposed to do these three main functions. Okay, now you are saying that I should replace my router with your firewall, right? Your firewall is a next gen firewall, you are best in the market, okay, blah blah blah, I believe you. Okay, so your firewall is supposed to do what? Routing lookup, policy lookup, NATing. You are a next gen firewall, right? Of course, you will do some SSL inspection. You will perform a lot of UTM functions, right? You may also be performing some traffic shapings. Who knows, right? Something more than the router, right? Of course, correct? After all, you are the firewall. So if each process is still taking a single millisecond, a 1 millisecond time, how much time did you took to process a packet? 6 milliseconds, right? So my question is simple. Are you saying me that in order to secure my business, I must compromise with latency? Because if I use your product, you are doubling my latency, right? Previously, I was having 3 milliseconds. Now you added 6 milliseconds, man. Maybe this will be a sales pitch for any other business, but if you try to sell this thing to a retail business or to a finance business, they will throw that product out. Yes or no? Would you like to wait in a line just to you have swiped up your card in a retail shop and like you are waiting for the banking to confirm whether your payment has been done or not? Would you like that experience? No, no. So that is a business critical thing, right? Why someone will buy your product? Make sense? What I'm saying?
Yes.
Yes.
So the point is, then how does a firewall maintain such a wide range of functions to ensure the security of the entire network? But at the same time, it also ensures that I do not add any latency, no matter what. Okay, or minimum to less. That is something which you will even not notice. Okay, so that is what the difference is. How do the firewall will achieve this? See, different products have a different way to process. Okay, but in the FortiGate firewall, to address this concern, the FortiGate firewall follows triple P model. Okay, triple P model. Triple P model says parallel, packet, processing. Okay, is saying I will follow a model which is called triple P, parallel packet processing. Now, what is this? Parallel packet processing. See what it says now, that when I will get a packet, okay, let's say for example, I got a packet, right? I sent the packet to routing lookup. Routing lookup said, okay, fine, it will be sent out through the WAN port. Okay, policy. Then I will check with the policy. Hey, do I have a policy? Yes, you have a policy. Policy is saying matching with the rule number 100. Action allow. Okay, do I have a NAT? Yes. Change the source IP to a certain IP. Source port will not be changed. Something blah blah. Okay, SSL inspection. Please check whether the traffic is good or bad. Everything is checked. Then to the UTMs, web filter, application control, DNS filter, IPS, antivirus, file filter, everything is being checked, then traffic shapings and all, and then the packet is sent out, right? So I'm waiting for each and every processes, right? That's why it is taking time. That means total time taken was 6 milliseconds, right? Now, instead of that, what it will do is, the parallel packet processing concept says that, hey, I will duplicate the packet what I have received. Okay, I will duplicate. That means the packet what I have got, I will create 2 packets out of it. I will send 1 packet to these processes, 1 packet to these processes. Okay, everyone is getting their own share. Now that means that everyone will give the verdict at the same time, correct? Right? So what the time your router took, same time will be taken by my device also. Got the point? Parallel packet processing.
Can you explain one more time?
Okay, say this.
Yeah.
It says that whenever you will send a packet to me, okay, whenever you are going to send a packet to the firewall will create duplicate packets. Okay, he will send 1 packet to some process, the other packet to some different process, so that every process is capable to process and give their verdict in the same time. They do not have to wait for the packets to come. Got it? Instead of going step by step, that is, okay, fine, first check routing, then this, then this, then this, what is happening is everyone is giving the verdict at the same time. Clear?
If suppose the policy will reject the packet,
Drop.
so it will block. And
Yes.
what about so duplicate packet will also be dropped?
Yes, because after all, it has to be a final verdict. If everyone says green, then only allow. If anyone says no, gone. But I will explain you this in much like better way when I will tell you about the life of packet. You will see a more granular picture about it. But just take a gist of it. That it is going to multiply the packet. That means duplicate the packet, and then it will send it to 2 different processors. That you guys start processing the packet. Do not wait. Okay.
So it just a duplicate, or it can be create the 6 packet for the 6 processes?
No, there is not. It's just a duplicate.
Duplicate, okay.
Yes. Okay. So that it will speed up the process. Okay.
Got it.
Fine. So this is how it is like going to address the latency problem.
So means only 2 packets.
Yes, 2 packets.
So, and if how the services are, for example, it's more than 10, like we can add application services also. So then in that case, it will take near about 5 milliseconds.
No. I will like come. Just remember that whatever the processes are here, right?
Mm-hmm.
They all are handled by some different processors. Okay, there are different processors. Okay. Now these processors are responsible to perform this task. So I give 1 packet to this processor, the other packet to this one.
Mm-hmm.
So now each processor, since they have got their own packets, then they can give the verdict at the same time, right?
Okay.
You do not have to wait that, okay, if the process number 1 completes, then I will take the packet. No, they will give the verdict at the same time. And this is why there is no additional latency. It will take as the same what your router took.
But in router, we have only like routing and policy and NAT. Okay. But in case of Fortinet, so it may be like routing, policy, NAT, then SSL, yes, UTM services, and then maybe we can add applications.
Correct.
Yeah. And we can say also some static NAT or
yes, correct.
Yes. Okay.
So these processors, there are only 2 processors which are sufficient to handle that.
Okay. Mm-hmm. Got it.
Now see, the point is, I will I have got the gist what you like guys are looking for, but I will like come to that point. Just wait for 2-3 minutes. Okay, let me just make one point very clear and then I will jump to that. And then you will get these questions cleared. Okay. Now see, triple P model structure says that once I receive a packet, I will multiply it, right? That means duplicate it and then I will send it so that the processors are able to process the packet at the same time. Hence, no additional latency. Clear? That is what the statement is. But I am fishy about this. I don't think it is going to work. Why? Because what you are saying me is that if there is a firewall, and let's say there is a single PC, okay, connected to a switch to a firewall, right? He is just watching a 5-minute YouTube video on the youtube.com, just a 5-minute clip. I think around thousands of packets will be shared between the client and the actual server. Yes or no?
Yes.
Yes.
I mean, in a 5-minute clip, thousands of packets will be shared. So are you saying me that all those packets which has been sent will be duplicated? And if yes, that means where the firewall CPU was supposed to handle just the 5,000, let's say that the YouTube and the client and the YouTube application shared 5,000 packets. So where the firewall was supposed to handle 5,000 packets, since you multiplied it by 2, now the CPU has to process 10,000 packets. Are you saying that? If yes, so does not it means that the CPU is getting overloaded? And if yes, then we all know that if the CPU or memory is getting overloaded, what will happen? Performance impact?
Yeah, slow. Then it will be slow.
Slow. So again, back to the same problem, right? Again, back to the same problem. If I use your device, you are giving me slowness, right?
Right.
Does really triple P functions in this way? Or is there any additional function in the FortiGate firewall that helps us to mitigate it? Right? Getting the challenge now? Okay. So one thing is clear that triple P will duplicate the packet. No doubt to it. Okay. But it does not duplicate all the packets. It only duplicates what? First packet. First packet of what? Of unique session. Okay. Means what? See here. If this PC, let's say the PC 192.10 was trying to access the YouTube, that's a unique session, right? Source IP 192.10, destination IP is something which the youtube.com gets itself resolved to, right? Correct. Once a session is established, then the traffic will flow is using the same session, right? Correct. So when the PC tried to send the first packet, that means SYN, YouTube is accessible with reference to HTTPS. HTTPS is a layer 7 protocol, which uses TCP at layer 4, right? So that means the first packet is always going to be 3-way handshake. Correct? SYN, SYNAC, ACK. Yes or no?
Yes.
So what I'm saying is that the firewall will always duplicate the first packet, not the subsequent one. Okay, because when it processes the first packet, he will know exactly, okay, fine, whatever the traffic will come. If it is matching the same session, then what is the route, what is the policy match, what is the netting that they have to do, and all, it will maintain itself, right? So no problem with that. Okay, so in this way, the firewall will try to mitigate the overload of the CPU. Now let me come to further parts. Okay, now I will jump to the CPU one more time, but let me cover one topic in here, which is called life of packet, that will give you a more clarity what I was saying in here, that how it will mitigate your latency. Okay. So just take a pause in here because I've got your questions and doubts that how it is like duplicating the packet is helping in here. Okay, so now let me explain you that in a broader way. Okay, so see here, life of packet. Life of first packet. And please note, this is very to the n number times important topic. I will be using life of packet concept throughout the course whenever I will troubleshoot or whenever I will configure the device. If you know this, 80% of your firewall is covered today itself. And I will prove you that, okay? Just follow the basics. Nothing else to be worried on, okay? There will be no if and buts. It's a clear-cut statement and like concept, what I will do, why I will do, that's all. If you know the reason behind that, why I am doing what, clear. The product is clear then, okay? So let's see here. When a packet is sent, the packet will be received on the interface. I will call that interface as an ingress interface, or you can call it as an incoming interface, right? Buffer, right? Whenever there is a packet, yes or no? Then see, the first thing that your firewall will do is integrity check. What it will do is integrity check. Why does it do it? Why there is an integrity check? To ensure or to confirm that the packet what I have received has not been altered or modified in between the path. There is a chance now. Let's say you have ordered something from Amazon and you have received a parcel, but the seal is broken. You would be doubtful, right? Maybe what I have ordered, someone would have replaced it, changed it, something, right? Correct? So why there is a seal? Seal is there just to confirm what? Integrity of the content inside the parcel, right? So how does a packet confirms its integrity? Any guesses? How does a packet confirms that?
Checksum.
Sorry?
Checksum.
Correct. Thank you. See here. No matter what that packet is, any packet, okay, that exists in the network, it's a layer 2 packet, layer 3 packet, layer 4 packet, layer 7 packet, whatever that packet is, it doesn't matter. See, IP header. Layer 3 header. Do you see this header checksum value here? 16-bit. Seeing my cursor? Is it visible?
Yes, with you.
Right? Oh, networkings.com. Oh, come on. Fine. Do we see this header checksum? Right now? So this will confirm whether the content of the IP has been changed or not. The IP header. Okay, because IP header will carry the protocols like OSPF, ESP, ICMP, right? There are layer 3 protocols, right? So these will confirm you that whether the header has been modified or not. Okay, let's see further. Layer 2. Layer 2 header is called Ethernet header, right? Let's see that. In the Ethernet header, you have CRC, frame check sequence. See here, 4 byte. Correct? This will confirm layer 2. Layer 4, let's talk about TCP. In TCP, do you have something like that? Checksum. Do you see this? 16-bit, right? UDP. Let's see the UDP protocol. Header checksum. Oh, sorry, this is IP header, man. Sorry, this is here. UDP header checksum. Do you see this? Got my point?
Yep.
So this is what your product will verify. always. Even it does one more thing before that, but like that action is something which is done on the buffer level by any device, by any network device. Okay, but that step I will discuss when I will learn about the clustering concept. Okay, there I will talk much more about the basics. But overall functioning with reference to the FortiGate firewall, when the packet is inside the firewall, so that is when the first thing is integrity check. Okay, it will verify the header checksum values to confirm whether the packet integrity is same or it has been modified. If it sees that something has been modified, it will discard the packet. Okay, silently drop, which you will see in the interface counters. Okay, now let's say the integrity check is pass. Then what? Then it will check captive portal or captive authentication, you can call it. Okay. Now, what is this captive portal or captive authentication? Let me put an example in here. You might have logged in into airports or like free Wi-Fi cafes, or maybe you have checked in hotels, right, where you get the free Wi-Fi, right? But you might have noticed that when you like try to connect to those Wi-Fi as SSIDs, you cannot simply connect and like send the traffic, right? No, they will ask you to enter the phone numbers or something to that you will get an OTP message, which you further enter into that for the authentication, and then you are allowed to access the Wi-Fi, right? Yes or no? Nothing is free. After all, you
Yes.
to authenticate yourself. That's your captive authentication. Okay. So here also we have a concept of an captive authentication where the firewall will say, stop. First, tell me who you are. If you authenticate yourself successfully, then only I will allow you through my device. Else, drop. So that is what the captive portal is. We will have a lab with reference to that. I will show you how. This is a very simple configuration though, but I will show you in the lab later on. See, the next thing after the captive portal, but yes, this is then something which is optional. If you want to configure it, you will do it. If you do not, you will not simply enable the captive. Okay, so it will bypass. So not a problem. But let's say the captive is not there, or maybe the captive authentication has been success. Then what? Then your firewall will perform DNAT. I will see that do I have any existing DNAT which is matching with the received packet format, and if yes, then modify the destination IP or the destination port as per what the DNAT is configured for. So he will first modify the destination IP or the port. If there is no DNAT matching as per what the packet you have received, the DNAT action will be bypassed. He will say there is no matching DNAT configured. Okay, then he will do RPF and routing lookup. Now, what is RPF? Reverse path check forward. Now, what is this and why this is done? Let me explain you this. Let's take a slight detour to understand the RPF concept. See, there are two types of routing lookup. Okay, there are two types of routing lookup. Okay, sorry for my writing though, but I think that is making sense. See, one is called whenever you perform the routing lookup for source IP, that is called what? Forward lookup. Okay, that is called forward lookup because, oh, sorry, my bad, man. Destination. Whenever you do the routing lookup for destination IP, that is called forward lookup because you are looking for the destination IP that, hey, how I will send the traffic towards the IP 888. Okay, it's via the WAN. So you want to send the packet in a forward direction, right? Out. So that's why we call it as a forward lookup. Okay. But whenever you do the routing lookup for source IP, that is called reverse lookup. And see, that will make sense to you as well. Let's take an example. There was a PC IP is 192.10. There is a router is connected to another PC. Another PC IP is 172.10. Okay. The PC is trying to ping to the PC A is trying to ping to PC B. So source is 192.10, destination is 172.10. When this packet is sent to the router, so if a router is doing a routing lookup for 172.10, that is called forward lookup. It will say, okay, fine, the packet has to be sent out via, let's say this is F0/1, sorry, 0/0, and this is F0/1. Okay, so it will say that the packet has to be sent out via F0/0. Okay, done. But when the packet has been sent out, and now when the reply will come, when the PCB will send the reply will look like this now, 172.10 and destination 192.10, right? Yes or no? When this packet is sent to the router, when router will do the routing lookup for 192.10, then it will say, okay, fine, this has to be sent out via F0/1. Then the packet will be sent out, right? So that being said, so it means if I do a routing lookup for the source IP here, can't we say that this is a reverse lookup? Because when the reply traffic will come, the source IP will be in the destination field. So is the term making sense when I'm saying forward lookup for the destination IP and source IP lookup is called reverse lookup? Is the term clear?
Yes.
Okay. Now, see here, why this is done? How is this useful, right? See, nowadays, most of the, even the router are doing these reverse lookup. Why they do that is to prevent you from, what was that attack? Spoof attack. Okay, so RPF check helps you to prevent yourself from the spoof attack. How? See this example. Let's say I have a firewall. Okay. A firewall has 4 interfaces. This is port 2, this is port 1, this is port 3, this is port 4. Let's say there is a routing lookup also, routing table. Okay, there is a routing table which says that static entry that 192.168.1.0/24 is reachable via port 2. Okay. The other static entry says 192.168.1.10/32 is reachable via port 3. The other one says 192.168.2.0/24 is reachable via port 4. Okay. Other one says 172.16.10.0/24 is reachable via port 1. Okay, clear? Now let's say the traffic is coming in this way. The packet is 192.168.2.1 who wants to go to 192.168.1.10. Okay. Now tell me, when the routing lookup will be done for 1.10, what it will match to?
Port 2. Sorry, port 3.
Port 3, right? Because of the
/32.
largest prefix subnet.
Yep.
Okay,
Yep.
fine. So it is matching with the port 3. But when it will do the reverse lookup, that is for the source IP. Here, 2.1, what it will match to?
The same?
Now, port 4. See?
Port 4.
Is here now, right? Correct? So in short, now, yes, is there a doubt?
Yeah. So your question is for like when they look for routing is 2.1, so then it will /24. Yeah, that's correct.
So it will see with, so it will know that, okay, this subnet is behind where? Port 4,
Yep.
right? So now the
Mhm.
firewall will be doubtful now that if this subnet is behind port 4, then how come I am receiving a traffic from 2.1 on the port 1?
Could you please like come again the same scenario again?
Yeah, again, see here. I'm saying clear with the routing table first. Clear
Yes.
with routing table.
Yes. Yeah.
1.0 is something, 1.10 is there.
And yeah.
Okay. So now what I'm saying is when this packet is coming, okay. So this is the source, this is the destination, right?
Got it.
So when the firewall will do routing lookup for the source 2.1, what it will match with? This route.
Port 4. Yeah, right.
Port 4, right? So now the firewall will be doubtful now that if the subnet is behind port 4, then how come I am getting a traffic from 2.1 on the port 1? Yes or no? What does the routing says? Routing says that if you want to reach 2.0/24 network, then go via port 4, right? That means that subnet is behind port 4.
Right.
If that subnet is behind port 4, then how come I'm getting a traffic from 2.1 on the port 1?
Yep.
Right? Correct? So that means what? That means someone is trying to spoof the packet into the network. And such a packet or such a traffic is termed as a spoof attack. Okay.
Okay.
So RPF helps you to mitigate the spoof attack. Clear? Clear now? So even before performing the forward lookup, the first thing that is always performed by the FortiGate firewall or by any devices nowadays is reverse lookup. They will do that. Okay. And this also does not only help you to mitigate the spoof attack, but also helps you to maintain the session entry so that the firewall or the router do not has to worry about that if there will be a reply, how I will send that packet out, because they have done it, right? They know that if a packet will contain the destination as 2.1, I know it has to be sent out by the port 4. Okay. And everything will be recorded down into the session. That's why we say that these devices are stateless devices, right? Or stateful. Your firewall is a stateless or a stateful device?
Stateful. This is stateless. This is stateless.
It can be both, I guess.
It can be both.
I think it depends on what model. Like, is it a next generation or is simple stateful or UTM?
Okay.
I think it's like a Cisco ASA is a stateless, and these are stateful. Next generation firewalls.
Okay, I will leave this question for the day when I will discuss about the session output. Okay. Okay. Because if I will try to answer that, that will create furthermore doubts. So I like want to deep dive into that point. Okay, so just I will like park this question. Okay, for you guys till the point when I will discuss the session and debug. Okay, fine. So see here, what happens is your firewall will perform the reverse lookup first. And if it is saying that, okay, the packet is coming from the same interface as per what my routing table is saying, then only it will go and check for the routing lookup for the destination IP. Okay. And if you have configured the routing lookup, then only he will move to the further next step. Okay. Let me first move these to slightly down. Okay. Now, see here. Let's say you have configured the routing lookup. Okay. If there is no route, the packet will be dropped. Okay. Let's say you have configured it. Pass. Then what? Then the firewall will perform policy lookup. Okay. He will perform policy lookup. Hey, do I have an existing policy which is matching with the received packet? If yes, then it will check, okay, it is matching with a policy number so and so. So what is the action based upon it? Is it allow or deny? The policy only has two actions. Either you are going to allow the traffic or you are going to deny the traffic. If there is no existing policy, please note that the traffic will automatically match with the implicit deny policy. That is policy number 0, which is always at the bottom. So the policy matches happens from top to bottom. Okay, clear? And how does traffic is set to be matching with the policy? Basics? Any idea?
Like for source and destination.
See, it will match these parameters: source interface,
Destination interface,
destination interface,
destination port,
source
source
address,
port. Sorry.
destination address, okay, destination port,
Port. Yep.
and protocol number. Okay, clear? These 6 parameters are matched, and all 6 must match to the policy what you have configured. If any of the single parameter is not matching, that policy will say that it is not matching with me, check next. Okay, all 6 must be matching. Clear? That's why I'm saying protocol number. Protocol means what? Whether it's a TCP, UDP, ICMP, or what kind of a protocol that is. Got it? Got it.
Yes.
Services.
Yeah, services. So services is generally combination of these two. Okay, fine.
Yes.
Okay. Now, so let's say you have got a policy which says an action allow. Then what? Then it will perform UTM or NGFW action. That means antivirus, IPS, web filter, DNS filter, file filter, video filter, okay, all those things. SSL inspection, flow based or proxy based, everything will be covered in this step only. Clear? If everything says yes, it is good, the traffic is good, nothing to worry for, then it will perform source NAT. Okay. And okay, fine. Before sending it out, let's see whether the source NATing has to be done or not. If you have configured the source NAT, it will perform the source NAT. After performing the source NAT, what it will do is it will perform traffic shaping. Okay, it will perform traffic shaping. That is just like a QoS. Please note this is an optional configuration. If you have configured traffic shaping, then only this will be performed. If you have not configured traffic shaping, it will not perform the traffic shaping. Once the traffic shaping is performed, then the packet is finally being sent out via the egress, or you can say outgoing interface. Out. Clear? Simple function. Okay. Guys, clear?
Yes, it's clear.
Okay, now say this. Dun, 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 dun.
So Rohan, sorry, for captive portal, so it's the internal process of
Firewall.
firewall incoming packet. Like for
Yes.
example, when we use a guest Wi-Fi in any organization or in any location like hotel or airport, so we have to enter our credentials for like we will get some portal for registrations. So
Correct.
the same process in firewall for incoming packet. Am I right?
Yes, correct.
Yeah. Okay.
Okay.
So in that case, like the packet should be what information like should enter in captive portal?
I'm sorry, what?
So like in incoming packet, ingress packet, so what information the packet should enter in captive portal, like source address, source MAC address, like
No. It's a normal packet only. But see, I will not jump to that point right now because I have not shown you the concept or like configuration to it. Okay, so just wait for me to touch to that point. Okay, maybe
no
like tomorrow we will be touching that, or maybe yes, tomorrow I think we will be touching the captive portal. Okay.
Okay, I think tomorrow is week off.
Tomorrow is like whenever we are going to have the next.
Okay. Thank you.
Okay. See ya. Hey, I was told to take only 1 hour class, but it is extending a little bit. I hope you guys do not mind, right?
No, continue, please. No problem.
Now see ya. So remember I said that triple P will duplicate the packet, right? And then it will send the packet to 2 processors. One of that processor is called network processor, and the other processor is called content processor. Got it? Actually, what the thing is, your CPU here, okay, which you will call it as an SPU, you can call it as an SPU as well. Okay, security processing unit or central processing unit, or in general term, main CPU. Okay. What happens is you have a main CPU. Okay. This main CPU has 2 components or 2 further processors. One is NP processor and the other one is CP processor. Okay. So NP processor is supposed to perform these tasks and CP processor is supposed to perform the UTM actions. Got it? Clear? Making sense?
Yep.
If you watch closely to it, the major difference with a standard router and a firewall is the UTM and NGFW action, right? That's the major difference, right? In terms of functioning. Yes or no? Correct? So that has been handled by a different processor itself. So when we say that the firewall follows a triple P model, what we are saying is that it will duplicate the first packet and it will send 1 packet to the NP and 1 packet to the CP processor. Got it? So that the CP will give all the verdict as well as the NP will give the verdict in the same time. Make sense now? Now it's out clear when I was saying that there will be no additional latency. Rather, he will also process it in a 3 milliseconds. Got it?
Yep.
Okay. Now see, no one is going to ask you this NP and CP and all. No one is going to ask you that, and it doesn't matter. Okay. But it's just a good to know fact that you should not be wary that, hey, the firewall will add a latency into the network. It will not. Okay. Except from some exceptional deployment, there are certain conditions where the firewall is supposed, it's like where you are supposed to see some additional latency that is dependent upon a certain deployment scenarios. Okay, because you want your firewall to perform a certain task. That is something. So apart from that, if you will talk in a general term, there is no latency that is your firewall is going to add on. Okay. Now, say this. The next is what else? There's one more thing. Yes. Now see, like I said, now that someone is trying to access YouTube. So he's, let's say for watching 5 minutes video, he's like going to send 5,000 packets, right? So that means all those packets will be handled by the main CPU, right? So that is not the case. Your main CPU is only responsible to perform the life of packet. That means initial first packet only. Okay. Clear? Rest all packets which belongs to the same session will be handled by whom? By the hardware CPU, which is commonly called as ASIC or NPU, Network Processing Unit. Okay. So do not confuse it with this. Okay. This is different. This isn't hardware. Okay, clear? ASIC. So your main CPU is always free to accept a new session. That bring it on. Okay, I'm free, not a problem. Because hardware CPU, because whatever the main CPU will do, whatever the action that he has done for the life of first packet, every step has been recorded, and that record is called session entry. Okay, so your main CPU will create what? He will create a session. That okay, hey, if a traffic is coming with so and so parameter, he is matching with a certain route, certain policy, certain action has been done, source netting, DNet or whatsoever. If there is a reply traffic will look like this, and this is what you have to do with the reply traffic. Everything is written in the session by the main CPU, and he will then hand off. He will hand off to the hardware CPU that now you take care.
So
The traffic comes.
the main CPU is like a combination of 40, 40 OIS and all these.
No. See, main CPU is this one, man. This SPU, what I was talking about, now CPU. This is main plus hardware.
Okay, got it.
Okay. This is then a structural diagram. I'm talking about the functioning.
Okay, so the main CPU is like our central processing unit. Okay, like include memories and hardware CPUs. Am I right?
Memory is different, but I'm okay. You can add memory here. Okay.
Okay, okay.
Okay. So memory CPUs are in here. Memory has there are two, it's like multiple memories, but like two memories are, one is physical memory and one is swap memory. Okay, which is used as a buffer. Okay.
Okay.
So that is a different one. But generally what happens is whatever your CPU has done, the main CPU has done, he will create a session to it, and then he will hand off that session to the hardware CPU.
So the main CPU is a like virtual CPU, or is the hardware is a combination of virtual and hardware
That
both?
depends now what kind of an product you have. It's if let's say you have a physical product, of course you have a physical CPU, right?
Okay.
Just like your laptop has a CPU, right?
Right.
In the same manner. But in the lab we have a virtual power. So of course our CPU and like memory is also virtual.
Okay.
Okay.
Got it.
Got it?
Yeah.
See, one thing I want to make very clear. Do not get carried away with reference to physical or virtual. Okay. Whether you are working on a virtual firewall or you are working on a physical firewall, the concept and the terms remain same. Okay. Same behavior, same troubleshooting, same approach, same packet flow, everything same, not a difference. Okay. Clear? Fine.
Where this hardware CPU placed in this diagram?
Okay, let me put it in this way. Okay, this is combination of main CPU plus hardware CPU. Okay.
Okay.
Fine.
Okay, sir.
Okay, but see, the main thing to take away is this life of packet. That's the main thing.
Want to know full form of DNet. What is DNet full form?
DNAT means destination NAT. That means you will translate either the destination IP or the destination port. SNAT means source NAT. That means you will translate either the source IP or the source port. Do not worry, NATing is something which we have a separate class for it. Okay, so I will be taking that, not a problem. Okay, fine.
Yes,
So Rohan,
Yes, please.
on the FortiGate dashboard, when we see the CPU utilization, it means it is a combination of the main CPU and a hardware CPU, correct?
Yes, you see the overall CPU utilization.
Utilization. Okay.
Yes, if you want to break it, you will run the command like get system is status perf. Okay, so that will give you the core label breaking. That for each core, what is the usage? Okay.
Okay, got it. Thanks.
Fine. Now see, How is this useful? I will just take 2 more minutes, okay? And how is this useful? Now, if let's say someone says that, what is the minimum configuration that you need to do in order to make sure that the firewall is allowing the traffic? See, it's very easy for us to now know that what is the minimum configuration that I have to do to make sure that anything is being allowed into the traffic. Sorry, into the firewall. Integrity check is done automatically, right? So I don't have to worry for the configuration for it. Captive portal is an optional configuration. DNAT is something, do I need a DNAT? If yes, then you configure it. If not, pass it. Route, yes, you need a route. You cannot miss it. So that means you must have a routing. Okay. Policy, yes, you need it, because if there is no policy, then it will match with a default policy that is implicit deny. So the packet will be dropped. So you need a route, you need a policy. UTM, you need it, apply it. You do not need it, do not do it. Okay. Source NAT is something that will also come to the point that do you need a NATing or not? If yes, go for it. If no, leave it. Traffic shaping is also an optional configuration. So the minimum configuration that you need to allow a traffic into your firewall is route and a policy. That's all. See? Right now? Okay. Or if, since you know this flow, now it's very easy for you to take a call that what all configuration you need to do in order to achieve a specific task, right? It seems easy, right? You like do not have to keep on guessing that something I might be missing, right? Okay. Clear. And you will also see how I will use the traffic flow with reference to the troubleshooting. Okay, when I will go within troubleshooting topics and all, there you will see that I will follow this as structure. Okay. So that's all for the day. If you have any questions and all, I was looking forward to also show you how to bring up the lab, but I think that we will continue in the next class. Okay. But for like today, I think this is sufficient. So if you have a question with reference to whatever I have covered, let me know. I'm happy to answer.
Yeah, thank you, Rohan. So, Rohan, can we get this recording on our portal?
Of course, everything is getting recorded. Okay, so as it's the class end, by like tomorrow, you will be receiving these recordings into your student portals.
Okay, thank you. Actually, I don't have any notebook today, so I'll check tomorrow. Recording and will make notes.
Okay.
Thank you.
Hi, Rohan.
Hey, hi.
Rohan, when is the week off for this class?
Okay, the class timing is from 9 to 11. Okay, and the classes are for Friday, Saturday, Monday, Tuesday.
Okay.
I was hoping to have the class on Sunday as well, but the batch decided that Sunday we should not have the class. So, okay, I'm okay with that. So we are going to have a 4-day class. Okay, Friday, Saturday, Monday, Tuesday. Okay.
Can we make it tomorrow, 5-day week?
Sorry, 4 days.
So 4 days. If you are saying Sunday not possible, so tomorrow can we do? Means
tomorrow is Wednesday.
okay, means I am saying 5-day week, or that's the structure only 4-day week.
I will answer that. Just give me a moment. Just give me a moment, man. Just wait.
I think it's a 4-day week.
No, it's a 4-day week, but I got his concern. Okay, just give me a moment. I want